go. The eye of the beholder. I think that's something that we all know as statisticians, but something we don't talk about very often. So as a background, my aims tonight are to give you a little grounding in a discipline that is almost dead, known as the Sociology of Scientific Knowledge. I'll present some data obtained using the methods of that discipline to explore how non-statistician researchers understand regression coefficients. Provide some historical framing for the current discussions of null hypothesis significance testing and p-values, and hopefully convince you that we statisticians would really benefit from a mature sociology of statistical practice. So some background, there is much effort globally towards improving statistical practice and statistical literacy, especially in biostatistics and in health-related research. But we can't build a bridge to best practice if we don't have a picture of what is sustaining and generating current practice. Statistical analysis is performed by real people in the real world, not in some kind of intellectual robot vacuum. And so to understand practice, we need to sort of reckon with the social character of statistical practice. And by that, I mean scientists and their beliefs, scientific institutions and their histories, the incentives and the reward structures that are in operation within those institutions. So if we want to change statistical practice, we need to find out what is in people's heads, find out how it got there, find out why it got there, and find out why it stays there. And it's at this point that you might be thinking to yourself, it's actually not that hard to change practice. We just need to get people to do the right thing, right? And of course, there are right and wrong things to do with statistical methods. There are applications that are consistent and inconsistent with the assumptions that underpin those methods. But not everyone has the same impression of what's right and what's acceptable. And that is a phenomenon of empirical interest to me. I'm inclined to think that almost everyone wants to do science the right way and wants to do good science. And it's these divergences in understanding that interest me and that I think we should spend some time with rather than dismissing as wrong and therefore uninteresting. Right and wrong are terms that are used within particular communities, and right and wrong have particular meanings in particular communities. Barry Barnes, who's an Edinburgh, not a colleague, but alum, wrote that what's proper in science is that which is communally judged to be proper. And so there is a space there for diversity, and that's where my work sort of sits. So how do we do this? How do we reckon with the social? It's sort of terrifying to engage with these qualitative ideas sometimes when we come from a quantitative background. So if you're sitting there feeling slightly bamboozled, don't worry. We have over 50 years of scholarship in the sociology of scientific knowledge to give us some pointers. And so I have here some do's and don'ts. Mostly don'ts, I've realised, reviewing my slides. The first important thing is to avoid restricting the analysis or avoid restricting the conversation to famous people. Martin Rudwick, in his great book about geology and the use of evidence in geology, wrote that we need to include in their diverse roles not only star performers but minor actors and walk-on parts. It is very easy for us to focus on the Andrew Gelmans and the Ron Wassersteins, and their opinions and views about statistical practice are very important and they're essential for shaping the discussion and providing leadership. But we're sort of kidding ourselves if we think that editorializing is going to have a meaningful impact on practice. We need to reach out towards the softer voices in order to get an accurate picture of what we can do to affect change sort of in the real world. We also need to recognise the disunity of the sciences, including the health sciences. And the disunity of the sciences was a sort of trendy thing to be writing about in the 90s and is set up sociologically by Karen Nossetna in her book Epistemic Cultures. But it's also been established empirically in the field of scientometrics. So here we have what this is a total scrape of the Web of Science and a visualization of the 224 subject categories in citation space. And we can see here, science is actually a network of quite diverse groups of scholars. And we can see even biology and medicine, the community that biostatisticians serve and support, even that is a diverse group, with some tendrils out towards the social sciences and some towards the environmental and physical sciences. And so we might expect diversity in practice in these different parts of science. And while it's fun to deliver sweeping generalizations, they're really accurate, and we should keep that in mind. Even these little red blobs in my PhD, I unpacked one of these into 8 further sub-clusters. So the diversity is staggering in science, and we need to keep that in mind. We also need to be mindful of institutional culture. It's very, very easy to kind of sling mud at individuals who seem to be doing strange things that we might disagree with or might think are incorrect. But scientists come up through institutions, and even within the same field, members of different institutions might have wildly different ideas about what is proper. And in this fantastic historical study, The Enigma of the Aerofoil, David Bloor notes that different scholars in aerodynamics worked in different disciplines and institutions whose traditions and reward structures diverged from one another. And those traditions and reward structures had a really powerful impact on the content of their science. That is a great read, especially if you have a thing about aeroplanes. There's a lot of cool aeroplane knowledge in that one. Finally, we shouldn't underestimate the power of disciplines. Training within a particular discipline tends to change how we see the world. And particularly in fields where the training is quite rigorous and quite rigid, our training exerts a deep hold on the scientific mind, so says Thomas Kuhn, and I'm inclined to agree. Our discipline is not our destiny, and we know that because statisticians themselves are quite diverse, but there are trends across disciplines that might explain some of the variation that we observe in statistical practice. The topic of this talk is this last don't, and that we shouldn't assume that our issues are necessarily modern. There are tensions, fundamental tensions at the heart of scientific practice, which underpin modern debates frequently. And when there's an issue that seems protracted and just impossible to resolve, I think we're quite likely to find some of these fundamental tensions at play. So I'm going to present 2 historical two concepts derived from the history of science to see if that can help us with the current discussion around null hypothesis significance testing and p-values in biostats. So first we have Duhem and his paradox on the left, and then we have whatever is going on the right, which is not the Rhino paradox, but is this idea in the title, mechanical objectivity, which I'll unpack. So Duhem's paradox. Scientific results can really rarely be interpreted without pulling on a whole set of existing and established theories. And the paradox is that by referring only to the content of our experiment, we can't really know definitively whether we've interpreted the experiment correctly. So we gain new understanding via the application of existing ideas. And this is put another way by Frederick Lancaster in saying that the right answer in science sometimes has the appearance of being a blunder. I think we know that in our own practice. And the flip side is true also. Sometimes the blunder has every appearance of a right answer. And Lancaster's not a sociologist of knowledge. He's an engineer who worked on airplanes in the 20th century. Great example of Duhem's paradox in what's known as the Great Devonian controversy. So in 1834, the geologist Henry de la Bache found some fossils in Devon, and they didn't seem to be consistent with existing understandings of geological history. And he turned up to his Royal Society meeting with these fossils, and all hell broke loose. And the key question was, does the understanding of the Earth need to be revised in light of these rocks from Devon, or has de la Bache made an error? And pretty predictably, people thought that he'd made an error. And he wrote that what he encountered was a good go of preconceived opinions against facts, which are so plain that the merest infant in geology could make no mistake. And If we think that scientific discourse in the 21st century has taken a bit of a dive, I encourage you to read this book because not only did Delabache get on the front foot in this series of letters, but he sketched unflattering cartoons of his colleagues and would post them to other members of the society with offensive annotations. So I find this encouraging. So much about modern science was there hundreds of years ago. So maybe we're not so bad with our tweets and our hot takes. But the key thing here is Duhem's paradox is at play. In the moment, when you're in that Royal Society meeting, sitting in your seat, you really can't know whether there's a period of 60 million years in the Earth's history that's unaccounted for, or whether this guy Delabache has just dug up the wrong thing or has mislabeled it. And getting the answer to that paradox took over 10 years. So the wheels of science sometimes turn pretty slowly. How might this have anything to do with regression coefficients then? Here is a little extract from one of my PhD interviews, which I'll contextualize a bit more down the line. But this nursing PhD said to me about regression coefficients, when they appear on her screen, it's fun. The numbers come up, all of a sudden it's beautiful. It's exciting, you get the answers. It's the end, crossing the finish line. It's the cake coming out of the oven. And there doesn't seem to be any paradox here. This sounds pretty definitive, right? The regression results pop up and then you're done with your study. However, while regression coefficients might have a stable statistical interpretation, that doesn't mean that readers or co-authors have arrived at the same conclusion about what the coefficients mean. And even if they sort of agree what the coefficients mean, they might not agree what the coefficients mean in terms of consequences for health. And so there is space here for difference in interpretation, even if the statistical or the technical interpretation is correct. So Duhem's paradox might be in play. And Bruno Latour describes this agonistic process. So frequently the appearance of regression coefficients is not the end, it is the beginning of this agonistic process, the shepherding of a new statement through what's called the agonistic field. And I've gone with this image of this footballer because I think we all know what this feels like, right? You've gotten to the end of your analysis, you've got your paper, and immediately the defense begins, and you need to justify it to yourself. Have I stuffed this up? Do these results make any sense? To your co-authors, to your reviewers, and finally to readers. And Latour hung around in a molecular biology lab for over 2 years. And he noticed that negotiations about what counts as proof or what undermines an experiment were frequently circular and disorderly. And that's in a Nobel Prize winning lab. So that makes me feel a bit better. I've certainly been involved in disorderly and circular conversations about regression coefficients and what they mean. Very few statements survive this process. And we know that in statistics in our own work, because the coefficients that are final and end up in a paper are usually like the minority of survivors from repeated iterative model building steps. And so we might think of that as an agonistic process in our field. And while this process is going on, the key thing is the attachment of what are called modalities to statements. And so what might be some modalities in public health? Well, I've got a few here. What might be some little niggling doubts that we can attach to regression coefficients that cause us to doubt them, cause us to call into question whether this is a discovery on one hand or an artifact on the other? And there are probably others that I could add. So my hypothesis for this work is that for public health researchers, regression coefficients are numeric proto-statements regarding the relationship between exposures and risk, and that they're subject to modalities. I'll explore that in some empirical data shortly, but we also need to address this idea of mechanical objectivity from the title. And I just want to highlight the paper on which I'm drawing, which is Dustin and Galison. And this is so good. If you find this talk even slightly interesting or engaging, do get yourself a coffee and print this out and enjoy it, because it's just glorious. So, welcome to Anatomy in the 1750s. what we have here is Albinus and his fourth muscular table from the table of the skeleton and muscles of the human body. And you might be thinking to yourself, why is there a rhino there? And the answer is that he thought the rarity of the beast would render these figures more agreeable than any other ornament. And I think he's right. If this is science in the 1750s, then sign me up. This engraving took 3 months to produce and represented a real advance in method. He drew up multiple grids at different scales and compared the example skeleton to the grid, very carefully measured everything, propped the skeleton up in a studio, forced a naked skinny man to stand next to the skeleton, who demanded a fire, which meant that the skeleton decomposed quite rapidly and apparently just smelled horrific. So this is commitment. This is commitment to accurate representation. Except that it's not, because this is not a picture of that skeleton that was in the studio. Albinus himself declared in his own book that in the instance where there was any blemish, he would mend it in the picture to render the likeness more beautiful. So the things that were less perfect in his images were rendered more perfect, and done so in a manner to exhibit the most perfect patterns. Now, as modern scientists, we cannot say this. We cannot write this in our methods section. Oh, if there was a blemish on my Western blot, so I just fix that up to exhibit a more perfect pattern. That is misconduct. So we clearly have a different take on what good science looks like. But in the 1750s, this wasn't just uncontroversial. This was a scientific ideal and really the pinnacle of anatomical scholarship. So through the 17th and 18th centuries, these exercises in judgment were laudable. Experience, artistry, and the judgment of the atlas maker, this was scientific. And science was much less the generation of data and much more the documentation of naturally arising experience through the prism of expertise and artistry. Until in the Victorian era, much of society, like manufacturing and transport, were mechanised, and automation, so as a virtue, becomes widespread. The Victorians don't want artistic renderings of things, they want the truth. 19th century scholars began to grow suspicious of these composite drawings, of drawings that combined features from multiple specimens in atlases. And so these gave way to type specimens, really accurate sketches of one actual skeleton, not Albinus and his corrective ideas. And finally, of course, they gave way to photographs. And this is a moral, not just a technical development. And it's a moral development that has quite profound consequences for us in statistics, where we found ourselves today. So in the Victorian era, what was really prized in a person was self-control, heroic self-discipline, and a tireless work ethic. But unfortunately, human laboratory assistants were quite lazy, inconsistent, and unreliable. And I'll make no comment about how that relevance to our period. But it was in this context that mechanical instruments entered the laboratory and worked there, and they were patient, indefatigable, ever alert, and could probe beyond the limits of human senses. So mechanical representation of stuff in science is not just faster, it is better. So mechanical objectivity emerges as a dominant scientific ideal. Interpretation, selectivity, artistry, and judgment themselves become to appear as subjective temptations that require mechanical or procedural safeguards. Human judgment, which was the height of scientific idealism, is reframed as a source of error that needs to be corrected. And automation and mechanistic procedures eliminate what's perceived as scientists' fallibility and their human weakness. So where we find ourselves now is that a big part of objectivity in science is the search for ways to replace individual volition and discretion with invariable mechanised routines. So where is it the case that machine good and human bad, even in the Victorian era? No, because the X-ray and the photograph were not perfect truth tellers, even in 1900. So the American Surgical Association commissioned a report, and Dr. Ames submitted the following. I have to my sorrow learned that the ray has many tricks. We cannot always believe what we see or fail to see, and a picture to tell the truth must have the plate, object and tube in the proper relation during the exposure. So here we have a modality from Dr. Ames. Is the tube aligned appropriately? That might change your interpretation, might put you in a different direction within Duhem's paradox. I had a bit of a look at some X-rays and their artifacts. This is an artifact caused by static electricity. And to my untrained eye, this looks like some kind of completely horrific disease. And I would tell this individual to seek urgent medical care. And that's why we don't let people with an untrained eye interpret X-rays. So unfortunately, the thing about scientific machines is that they need to be set up just so. And mechanized images are frequently distortions of reality, not uncomplicated representations. Despite our best efforts, our best pursuit of a mechanically objective representation, we still need expertise. We still need a person, a practitioner with experience, and we need that seeing eye in a judgment. So the medium might radiate authority, even as the practitioners are wrestling with the deceptiveness of the technique. And as a statistician, that feels very familiar. And so despite their limitations, mechanical representations retain an epistemic privilege. They just have this aura of superhuman power. Does this help us think about null hypothesis significance testing and why we can't seem to get rid of it? I think it does. Because null hypothesis significance testing is a mechanistic and procedural safeguard. And it's already been framed in those terms, just not linked into this historic change in ideals. So Edwards in 1972 wrote that what used to be called judgment is now called prejudice, and what used to be called prejudice is now called a null hypothesis. So viewed through this historical lens, this trend in statistics towards mechanized, automated inferential procedures is sort of unremarkable. And it's also unsurprising that we're struggling to produce change because we're pushing back against what is a really dominant scientific ideal, that so mechanized science is better than judgment or expertise-driven science. So some more research questions for me emerging from this are, are regression coefficients understood by researchers as facts, as being mechanically objective? And how do public health researchers navigate the challenge of handling artifacts in regression? So how do they navigate Duhem's paradox? To explore this, I conducted 45 interviews with academics who study health equity. And these interviews were carried out in 8 countries and represented 15 disciplinary backgrounds. Almost all my interviewees are at professorial level, and that's important to keep in mind. They're a part of my PhD, which is focused on disciplinary difference, but I did have a section in the interview about statistical practice. So interviewees broke up into the following 4 groups. Some mostly did their own quantitative analysis. Others did not conduct any of their own quantitative work anymore. I interviewed 3 statisticians who did quantitative work for others, and there were 2 qualitative researchers who did not engage with quantitative work. So as is often the case with qualitative study, you come in with your research questions and then your interviewees immediately blow your mind with something you never even thought about. And when discussing the challenge of quantitative work, interviewees time and time again were presenting it in terms of deciding which results have meaning and which results don't have meaning. And I had never really thought about this before, that not all statistical results have meaning. And so straight away here, we see a window for even mechanically generated inference to be meaningless. To get a deeper sense of how interviewees were handling and interpreting their regressions, I asked them whether they thought about regression as a process of discovery. Are they excavating somehow towards a bedrock truth that regression supports them to uncover? Or are they building a model as a representation which they understand it bears their own design and their own imprint? So starting with the folk who tended to view regression as discovery, they tended to reminisce about a particular result during their career that they viewed as a discovery. This geographer said that for them, the model was the discovery in this instance. We ran a model and we're not expecting to see a smaller inequality among populations that had greater access to whatever it was. I wasn't expecting that. It was a bit like an archaeological process, sweeping away the soil and suddenly there's Excalibur. So for whatever reason, in this particular instance, this researcher was able to recognize what they had found as a discovery, as Excalibur. But that was pretty unusual in my interviews. More common was something like this. When faced with an uncertain result, this interviewee said, I'm always a bit cautious. If you get something that looks weird, check it and see, and maybe test it on a split sample, another data set. It should make sense. But they didn't rule out the possibility that you do find something completely left field. That may or may not be correct. At this stage, you don't know what they are. So here, clearly, knowledge from outside the experiment is required to interpret the result. This interviewee's statement is a pretty neat summary of Duhem's paradox in practice. Consistently, interviewees talked about these confirmatory investigations of unclear results as supporting their interpretation of the regression. These investigations don't provide an interpretation themselves. They support the researcher's interpretation. It is you who does not know what the regression means, and it's you, the analyst, who needs to come to a decision. The researcher decides whether a result has meaning or is an artifact to be dismissed. So despite their mechanistic origins, regression coefficients don't seem to speak with the words of nature as we maybe might expect them to. The coefficient is a sort of garbled statement that needs to be treated with caution and cross-checked against other sources. But interestingly, not all coefficients were treated this way, and not all coefficients received the same skeptical treatment. This is the same statement, but I've just highlighted this sentence here, this idea that the coefficients should make sense. And this was a pretty widespread view, which seems to suggest that results which fit with the researcher's existing understanding are somehow different to results which conflict with the researcher's existing understanding. A similar idea here. This researcher said, my radar would be up more if the estimated effect is in an unexpected direction, or it was significant when I thought it wasn't going to be. I guess once that happened, I don't just take it at face value. But yeah, that's it. But I don't tend to do that for results that are more expected. So if the interpretation of the coefficient varies depending on whether it makes sense to the researcher, then regression coefficients are not mechanically objective. They require a seeing eye. And that researcher went on to say, I think you have to take those unexpected results, but view them with a lens of common sense. And the statistician in me says, yes, you should review your regression coefficients with a lens of common sense. That is very sensible. But the sociologist in me says, wow, this is interesting. This is a pretty explicit statement that says, I will bring what I already know to my model, and I will interpret it through the lens of what I already understand, which is sort of not the mechanically objective ideal. And it seems like good old Albanus and his rhino, we're trying to eliminate the disagreeable from our work in quite subtle ways. And maybe we're more like this kind of science when we're faced with regression coefficients than we want to believe. Some interviewees, especially epidemiologists and economists, sort of went around in circles about whether regression supports discovery. These seminal findings in the literature suggested that regressions do uncover real relationships, but this persistent nagging sense of an awareness of bias stopped interviewees from deciding that regression equals discovery. For example, here's an example of a pretty cyclical little journey that this interviewee and I went on together. They said, I'm more on the trying to find what's real side, but it's hard to ever be truth when we have so many caveats with measurement. I hope I'm getting closer to the truth as I'm building, but then I guess I am building. Those estimates inform intervention, so let's hope there's some truth to it. I'm hedging, I'm in between, because of course it's not perfectly true. So in the space of a few sentences, this research has gone from, oh no, we're finding what's real, to it's not perfectly true. And I am building something, constructing something perhaps. And this happened with regularity. So this economist said, I don't generally, or do I? I've changed my view about the world following a regression. My priors have changed. So in that way, I'd be in the first camp, which is model is discovery. But in general, I'm in the second camp, which is model is construction. So it's only in very specific instances that we permit ourselves to acknowledge a discovery via regression methods. It seems like we sort of want to have it both ways. And when I say we, I mean researchers in public health, just to clarify. It does seem to be difficult to answer this question, which to me is interesting. A common rejection of my premise involved smoking and lung cancer. So this doctor said, smoking does cause lung cancer. You have to be philosophically nimble to say that's somehow not a generalizable fact. You'd hope your model or your control study or cohort study picks it up, and your model is therefore measuring something that is true, but it will have error due to statistical imprecision and the three sources of error: confounding, selection bias, and measurement error. So regression models might access true relationships, but it reflect them imperfectly. And this seems on its face like a pretty good way around Duhem's paradox. But for this to work, you need to know the truth when you run the model, and that's pretty unusual in scientific settings. It's only in cases like this where we know the true relationship that we can recognize it and recognize the error. In the situation where we are new to the model's new to us, we can't be so sure, and so the paradox persists. I'll move on to interviewees I spoke with who tended to view regression more as a process of construction. And they described regression models as a picture of reality or a sketch. Epidemiologists and economists tended to locate any lack of correspondence with reality within the technical limitations of regression methods. So this professor said it's an imperfect representation of reality because there's always confounding, and the variables and instruments themselves are imperfect. So the problem lies in the difficulty of the technique. However, social scientists tended to emphasise more the role of their own values and choices. So this geographer said that regression is a representation that you know, as a researcher, you're constructing. Your own principles and epistemological position are vital for how you've gone about that process. And it's not like there's some sort of definitive truth out there. It's about thinking about defining a question, your own values, and the decision-making you implement throughout that research process. Surprisingly to me, but maybe not surprisingly to you, the other group who agreed with that geographer were statisticians. And the statisticians I spoke with repeatedly reinforced the role of the analyst in shaping conclusions. This biostatistician said, the coefficients represent help. They represent help to answer my questions. So they are the possible effects of exposure on outcomes. And I clarified there that the coefficient is help to answer the question. The coefficient is not the answer, and that is what they meant. So again, it's the researcher who decides. And if models are not answers, then this suggests that they don't perfectly capture or reflect reality. And this was a widespread opinion. So an approximation to relationships, regression models represent a piece of reality, some view of reality. They'll never fully describe reality or be a partial representation of truth. So 10 interviewees all up express this view, and it really does seem like a pretty resounding rejection of the idea that you just run your model and the truth comes at you. The researcher is involved in deciding exactly what slice of reality has been presented. So what about these modalities, the crash tackles on the way from statement to fact? I'll just present some of the more common ones that I uncovered. A key feature is how the model is set up. So these public health researchers discussed decisions in the model building process and choices made in data management. that they would want to know that information before trusting a coefficient. Another key factor is the study design. Researchers mentioned that, for example, if they were looking at a regression that was coming out of a randomized trial, they'd feel differently about that compared to a quasi-experiment or something descriptive. Researchers also talked about the importance of the research question, and I kind of wish I drilled down a bit further on that. I'm slightly unclear on how the question itself might influence the veracity of a coefficient. If anyone has thoughts on that, please let me know. And finally, data quality and availability were widely discussed. So you need to have good data. Good coefficients are more likely to come out of good data was the consensus. And interestingly, if any one of these things was perceived to be missing or inadequate, then the results could be dismissed. And so maybe it's because of this that it's only in pretty unusual cases that the whole list is satisfied. And I asked researchers, how often do you see work that ticks all the boxes? And the impression was sort of rarely. And so that might be why regressions are, by default, sort of mistrusted, because researchers perceive problems not with the regression, but with these features of the work that they're encountering. And really nicely summarised really this whole story by this professor of epi, who said that what you get out of your regression model depends on how you set it up. And as statisticians, this is not news, but it's an interesting echo of Dr. Ames and his sorrow and disappointment at his X-ray machine. He was saying the same thing. We're wrestling with the same challenge, and that is that the analyst sets up the instrument and therefore has a lot of influence over what it outputs. And the analyst is an important part of the process that in mechanically objective procedures is often downplayed or neglected. So generally, the output of regression models were not viewed as definitive or conclusive, and regression coefficients didn't seem to be understood by these researchers as being simply mechanically objective. This is pretty complex, really, what emerged. These models can discover, except sometimes the results don't make sense, and if the results don't make sense, you should be cautious and skeptical. There's a partial reality being represented, or a piece of reality, or some view of reality being represented, and you should use your common sense. But you should also note the technical limitations and the role of the researcher and the impact of the study design, the modelling process, the research question, and data quality. I think for me, none of this was shocking or surprising. This is a picture of what I would consider quite a conscientious approach to the interpretation of a regression model. But this is hard to do, and it's even harder to teach. We don't really teach this very often, especially out in the disciplines, in introductory programs. It's pretty difficult to provide a nuanced picture of all of these things in training, and maybe that's something we could think about. But if this is what we want instead of the mechanistic procedures, then we're probably going to need a slower science. And so I'll just finish up with some brief thoughts from my interviewees about null hypothesis significance testing as being anti-thinking. So this sociologist said it pretty straight, that instead of using those mechanistic procedures, researchers need to think. And this epidemiologist elaborated a bit more, saying that when we use mechanistic procedures, we suffer a loss in detailed thinking, that these procedures simplify our thinking. When we use hypothesis testing, young students are learning to reduce their thinking to a yes, no, and are not looking at the data in detail. And so this is the price perhaps paid by mechanical procedures. But there is also a gain that we don't seem to discuss very often in these debates. And there is a lack of space in science and in academia. And there's a wide literature that documents the perceived lack of time and space in a modern scientific career. My interviewees also commented on this. Two interviewees on different sides of the Atlantic in different disciplines described themselves as being like a hamster on a wheel, or like rats running on a treadmill, trying to get funding, trying to teach, trying to do research. You know, it's a tough balancing act. And if mechanical inferential procedures offer a bit of a shortcut, and a shortcut from all of this, you know, maybe if the trade-off feels kind of sensible in that context. And interviewees also, a couple of interviewees said that they wanted to improve their statistical practice and their statistical literacy, but they just didn't feel that they had the time or the space to step back from the track that they found themselves on. So if we're going to ask for a pushback against these mechanical procedures, we need to recognise what we're really asking for. What we're asking for is a science that's a little bit more like the science that produced this engraving, a science that values judgment, discretion and artistry. And that might be why we're not getting very far. If we want progress, we really need to build a case for a new science in public health. And given the fragmentation of science, that's a pretty tall order. But I'm hopeful that work like the work I've presented this evening can help us to have the conversations that we need to have and can help us to meet scientists where they are. I think a mature sociology of statistical practice can help us move beyond those editorialized complaints and recognise that in some spaces, reaching for mechanised inference might feel like a trade-off, which feels kind of sensible. So I'll leave it there, and I look forward to you releasing your modalities.
Thank you very much, Taya. It was a great talk. You've asked some big questions there. I'm sure you've left us plenty of space for discussion, which I guess is very appropriate. So, I'm sure many of you have questions. So I'm hoping that you have a raise hand button. So anyone who wants to ask a question, if you go to the participants screen and click on raise hand. I don't see anyone yet. Oh. Can someone tell me if they do see a raise hand button, just so I can confirm that that's the case? Oh well, until we. Oh yes, here we go. So Andrew Wade.
How are you doing? I'm Andrew Wade. I'm probably myself an education statistician. There's been a big push to attract people into STEM, into statistics, mathematical type techniques. I guess, is there a need to change the perception of statistics being very quantitative? And I guess it sounds like from your saying that, and I agree, that the more creative aspects, the more philosophical aspects are being left out. And can they be used to make statistics as a profession more attractive to potential students? Because at the moment, it doesn't have that perception. And then the question then is, do our courses, as they are currently structured in universities, enable that sort of more philosophical approach?
Thanks, Andrew. I think that's a great question, and I agree with you. I made it through introductory stats in 2 different undergraduate degrees before I got to a master's, and I thought, wow, the good stuff we sort of leave to the end. And I think it is at that advanced level that we recognise that statistical practice is more art than science, maybe. And some of my interviewees actually talked about their own practice in this way. And they use that term, they described it as a qualitative process, and it's sort of interviewing of the data and a dialogue with the data. And I do think that there are different framings for the profession that might make it seem as exciting and kind of mysterious as I've found it to be.
Okay, thank you.
So if you have a question, please raise your hand like Andrew did. And when you finish your question, you can lower your hand. Andrew, I'm presuming you don't have a second question. Okay. No hands raised, so I'm going to pitch one of my own. So Taya, I noticed at least I didn't see any use of the word uncertainty in your slides. Did no one talk about uncertainty?
It's a good question. I guess the uncertainty. There was a lot of discussion about sample size, a lot of discussion about work that was underpowered. But no, I mean, and this was a predominantly non-statistical group, and I did ask them, you know, what are the markers of really good empirical research for them? What are the markers of really poor empirical research? Off the top of my head, I don't think there was a lot of discussion of uncertainty, which is probably a bit of a shame.
So if no one raises their hand, I get to keep asking questions. Oh, Jess.
Thanks, Taya, for a really fascinating talk. This is a glimpse into the world of a different side of statistics, which was really, really fascinating. Thank you. I guess when you were describing this approach of sort of coming back and thinking about things and using your prior knowledge to kind of inform what you see in your results, it really made me think of the way we try to teach causal inference these days, like making people think about the underlying causal structure of the situation they're considering, and then using that to, you know, inform their analysis and interpret their results. Was there any sort of mention of thinking causally or anything like that in your interviews?
Yes, there was, and this discussion, this presentation of null hypothesis testing as sort of anti-thinking, it was there. People discussed it being that it represented a limit on causal thinking, and it discouraged sophisticated causal thinking, and that what these professors really wished their students would do more is bring that causal thinking into their analysis, and DAGs were discussed by a couple of interviewees. Happy to, I actually have a chapter section on that, so if you want to get in the weeds of that.
Thanks, Taya. Thanks.
And I will say that, you know, this is a glimpse into another side of statistics for sure. But so far, this is a world that has a population of one, and that's me. So the door's open. I'm sort of hoping that over my little career, I can gain a bit of momentum with this kind of work. So if you see applications or questions that might be helpfully answered using these methods, do reach out.
Thanks, Jess. Lyle has a question.
Here I am. Thank you, Damian. I'm coming to you from the kitchen. And Taya, thanks for a wonderful presentation. My partner Louise is a health sociologist, so we thought we'd hit the jackpot. Biostatistician and sociologist. I wanted to get your thoughts on mandatory, at least one subject in history and philosophy of science for anyone who does an undergraduate degree in science or a quantitative discipline, and how you think things might have gone if you'd been in medical research or laboratory stuff, because you've dealt with health equity and public health sort of stuff. So do you have a sense of how you might have fared in, you talked about the labs a lot, but you've mostly dealt with equity and the social sciences side of things. Is that right? So I'll let you respond to those two things.
Thanks, Lyle. Well, I think that's a bit of a, like, Dorothy Dixer, really. Like, of course, you're looking at someone who has a real love for philosophy of science, history of science, and it's really enriched my own approach to science. And it's so comforting to learn that these issues that can get very heated and nasty feeling, you know, they're not new, and scientists before us have navigated these precise difficulties. I think it can only be good for more scientists to learn about the history of science. That's a no-brainer. And in terms of the context, a lot of the literature that I've drawn on was laboratory-based, and there's an unfortunate bias in both the philosophy of science and the sociology of science toward physics. A lot of the existing theory has come from studies of physics or molecular biology. And so there are really detailed, fantastic case studies in the molecular biology labs that seem to present a similar picture, but the question of statistical practice is wide open. I'm not aware of any other scholar who's currently asking these kinds of questions.
Neither am I.
And so, you know, maybe that's a future project, is to speak to some benchside scientists.
Great, thank you.
So we have a question from John.
Hi, thanks, Damien. I was just about to rush off and grab something, but it was very nice of you to leave so much time for discussion. But we should try. I was surprised by your comment about questions or research questions or whatever, because it seems to me that we can't hope to understand what a regression coefficient means unless we see it as providing an answer to some kind of question about what why are we interrogating these data? We're interrogating them to answer some question, we hope. Could you just try to speak to what the issue was there? Nobody seemed to see regression as answering research questions, or you didn't see that link?
Yeah, that was me, unfortunately, freestyling in front of a great group of critical listeners. The topic of questioning is a really interesting one, and it is the one thing that beat me over the head reading the transcripts, is this cardinal importance of the question. And but what was interesting was that interviewees frequently set up considering the question in opposition to considering methods. And there was this widespread sense that it's possible to focus on one or the other in modern academia. Researchers, not all, but most, felt a real tension between dedicating their time and effort to developing important questions and dedicating their time and effort to developing methodological capability or churning stuff out of the methodological pipelines that they'd set up. And of course, you know, regressions hopefully are answering questions. that makes sense. But I'm not clear why, what I wasn't clear on was how one question might make a regression coefficient more trustworthy than another question. I guess it probably comes down to the correspondence of the model that's been fit with the question that's been outlined in the introduction. And, you know, we know that sometimes doesn't quite work. And that might be a modality that researchers are attaching.
Thanks. Mysterious, yeah, definitely a whole new world trying to understand what goes through people's heads when they do statistics.
Yeah. And it's a frightening but humbling.
Yeah. Thank you.
I think we have time for one more question. Does anyone wish to ask? Nicholas.
Yes. Coming from a Berlin machine learning group, we are just trying to figure out what causality could bring, and because it's sweeping into machine learning. And it's the conflict between Judea Pearl and Andrew Gellman. Have you had a look at this discussion, which is pretty hot? I can provide a link, which are 100 pages back and forth between Andrew Gellman and Judea Pearl and their respected friends. So have you had a look at this kind of conflict from your point of view?
Thanks for the question. And I am aware of the controversy, and I had planned a whole thesis chapter on causality, but I decided to abandon it because it was probably going to take me as much time as the rest of the thesis to unpack. What I can say is that disciplinary training really does drive ideas about what good causal inference looks like. And in my sample, interviewees from different disciplines had pretty sharply contrasting ideas about causality. I don't think I'm able to comment on that particular debate, but if you want, we can take this offline and I can take a look and try to be helpful.
Yeah, because I think you should rather speed up. There is also Imperial College. This is about medical imaging.
Mm-hmm.
So this is now via machine learning and deep learning and all that stuff. It is sweeping into actual practitioner problems, resulting in how to interpret medical images. You know,
Mm-hmm.
Imperial College is now engaging in that. And even internal problems arising between medical practitioners, meaning not statisticians or not machine learners, and the interpretation of some members of this group in Imperial College. Just really your theoretical conflict really is sweeping into relevant for on day-to-day basis on interpretation of medical images. So this rather becomes very, very hot in machine learning now.
Mm-hmm.
And nobody knows what it could mean, you know. So the question of causality and the reflection on that, maybe from a point of sociology, would come in rather handy right now.
Thanks. And I think, I think if we see diversity in ideas around a method as straightforward as linear regression, then it's guaranteed that we'll see diversity in interpretations in those more complex methods.
So thank you, everyone. We've come up to time. That was a great discussion and a fantastic talk, Taya. I'd like to thank you for being our guest tonight and giving a great talk. I'd like to thank Emmy and Lizzie for organising tonight's event, and the rest of the branch council for organising all of our various events that we have. Just a reminder, we have a workshop later this week on Julia. We have a statistical consulting event next month. And if there's any events that you're particularly interested in seeing, get in touch with us and we'll try to organise it for the future. And finally, a big thanks to all of you. Thanks for coming to our event tonight. I wish you all well and hope to see you at our future events. Keep safe and good night.